Greenland is characterized by its extensive ice sheets that dominate the landscape. The vastness of Greenland's ice sheets highlights the significant presence of ice in this geographic area. Glaciers show deep cracks and fissures because of immense internal pressure. The slow, continuous movement of glacial ice contributes to the formation of these crevasses. Glacial ice deformation occurs due to the weight of overlying ice and gravity. The depth and pattern of cracks reflect the stress distribution within the glacier. Glacier calving is a natural process where icebergs break off from the edge of a glacier. This process contributes to ice loss and sea level rise. Calving events can vary in size, from small fragments to massive icebergs. The breaking of icebergs is a dramatic display of the dynamic nature of glaciers. Polar bears depend on ice flows as a critical habitat for hunting and survival. The solitary nature of polar bears is closely linked to the diminishing ice cover. The ice flow serves as a vital platform for polar bears to access their primary food source, seals. Decreasing ice flow size directly impacts the hunting success and survival rates of polar bear populations. The ice flow provides a crucial resting and breeding ground for polar bears. The polar bear's hunting strategy at a seal hole exemplifies the predator-prey dynamic in the Arctic. Polar bears rely on seal holes as primary hunting locations due to the seal's need to surface for air. This predator-prey relationship is crucial for maintaining the balance of the Arctic ecosystem. Climate change threatens this relationship by reducing sea ice, impacting both polar bear hunting and seal habitat. Seals are adapted to the frigid marine environment of the Arctic Ocean. Seals exhibit graceful underwater movement, facilitated by their streamlined body shape. Bubble trails are produced as the seal exhales, demonstrating its breathing cycle. The seal's physiological adaptations allow it to thrive in extremely cold conditions. The Arctic seascape presents a vast expanse of frozen ocean. Icebergs of varying sizes dot the frigid waters, creating a stark, beautiful landscape. The scene emphasizes the harsh environmental conditions of the Arctic. The Arctic's beauty is defined by its starkness and isolation. The frozen ocean is a dynamic environment, constantly shaped by natural forces. Ice caves exhibit a unique crystalline structure that refracts light, creating a mesmerizing blue glow. The blue light within ice caves is a result of the absorption and scattering of light by the ice crystals. Impurities and air bubbles within the ice can also influence the color and clarity of the light. The phenomenon of blue light in ice caves showcases the interaction between light and matter at a molecular level. The Aurora Borealis is a natural light display in the sky, predominantly seen in high-latitude regions. The aurora is caused by charged particles, mainly electrons and protons, entering the atmosphere from space. The Aurora Borealis, or Northern Lights, is the name given to this phenomenon in the Northern Hemisphere. Icy surfaces reflect starlight, creating a visual connection between Earth and the cosmos. Reflection on ice demonstrates the principle of specular reflection, where light bounces off a smooth surface at a defined angle. The clarity of the reflected starlight depends on the smoothness and purity of the ice surface. Atmospheric conditions, such as humidity and temperature, affect the formation and maintenance of reflective ice surfaces. The reflective properties of ice can be used in astronomical observations to enhance the visibility of faint celestial objects. The mirror effect created by ice highlights the interconnectedness of terrestrial and celestial environments. Inuit wooden boats represent a traditional way of life adapted to the Arctic environment. These boats symbolize resilience and adaptation to harsh climatic conditions. Navigation through icy waters requires specialized skills and knowledge passed down through generations. The Inuits' traditional lifestyle demonstrates a deep understanding of the Arctic ecosystem. The Arctic Sea supports a diverse range of marine life. Whales are a key component of the Arctic marine ecosystem. The icy waters of the Arctic provide a habitat for various species. Marine biodiversity is essential for the health of the Arctic ecosystem. The Arctic region's biodiversity faces threats from climate change and human activity. The rugged Greenland coastline features a dramatic convergence of icy mountains and the ocean. Glaciers carve through the mountains, creating fjords that extend into the sea. The interaction between ice, land, and sea shapes the unique geological features of Greenland. Melting glaciers contribute to rising sea levels, impacting coastal ecosystems. This dynamic environment provides a habitat for diverse marine and terrestrial life. Arctic reindeer have adapted to survive in extremely cold environments. Reindeer possess thick fur and specialized physiology to conserve heat in sub-zero temperatures. Reindeer play a crucial role in the tundra ecosystem, impacting vegetation and nutrient cycling. As herbivores, reindeer influence plant distribution and growth patterns across the Arctic tundra. The Aurora Borealis, a natural light display in the sky, illuminates the Greenland landscape. Glaciers, large masses of ice, sculpt the Greenland coastline through centuries of erosion. The ocean reflects the dynamic interplay between the aurora and the glacial landscape. Greenland's unique environment showcases the convergence of atmospheric phenomena and geological formations. The cinematic composition captures the grandeur and beauty of Greenland's natural wonders. Albedo is the measure of how much light that hits a surface is reflected without being absorbed. Ice surfaces have a high albedo, reflecting a large percentage of incoming solar radiation. The high albedo of ice contributes to the regulation of global temperatures. Melting ice reduces Earth's albedo, leading to increased absorption of solar energy. Changes in ice albedo have significant implications for climate change and global warming. Meltwater streams are formed by the melting of ice due to rising temperatures. These streams act as indicators of the impact of warming temperatures on ice sheets. The carving of paths by meltwater illustrates the erosive power of water on glacial ice. Increased meltwater flow contributes to the overall reduction in ice sheet mass. An ice core sample contains layers of ice, each corresponding to a year of snowfall. The ice core sample traps atmospheric data from each year, providing a historical record. Analysis of ice core samples reveals past climate conditions and environmental changes. Ice core layers provide a chronological archive of past atmospheric composition. Studying ice cores helps scientists understand long-term climate trends and predict future changes. Ice crystals exhibit a hexagonal structure due to the arrangement of water molecules in solid form. The hexagonal arrangement of water molecules is the fundamental building block of ice crystal formation. Hydrogen bonds between water molecules dictate the specific angles and structure of the ice crystal lattice. The formation of ice crystals involves a phase transition from liquid water to a solid state. Impurities in water can disrupt the formation of perfect hexagonal ice crystals. The unique structure of ice crystals influences their optical properties, such as light refraction and reflection. A glacial moraine is a ridge-like landform composed of rock and sediment. Moraines are formed by the erosive and depositional action of glaciers. Glaciers erode the underlying bedrock, transporting debris which accumulates to form moraines. Moraines provide evidence of past glacial activity and the extent of ice cover. The ice sheet edge marks the transition between ice-covered and ice-free terrain. This boundary represents a significant environmental interface. The ice sheet edge is a dynamic zone, influenced by climatic factors. The location of the ice sheet edge is critical for understanding glacial dynamics. An iceberg graveyard is an area populated by numerous grounded icebergs. These icebergs represent a significant discharge of ice from glaciers. The scale of the iceberg graveyard visually demonstrates the magnitude of glacial ice loss. Grounded icebergs become stationary, accumulating in specific coastal areas. Iceberg graveyards serve as visual indicators of climate change and glacial retreat. The density and size distribution of icebergs in the graveyard provide data for climate models. Arctic terns undertake long-distance migrations, connecting Greenland to various global regions. These migrations demonstrate the interconnectedness of ecosystems across vast geographical distances. The Arctic tern's migration is one of the longest known migrations in the animal kingdom. Migration patterns are influenced by seasonal changes and the availability of food sources in different regions. Ice algae are a type of algae that grow on the underside of sea ice. These algae form the base of the Arctic food web. The location of the algae allows them to capture sunlight filtering through the ice. Ice algae are a primary producer in the Arctic marine ecosystem. The growth of ice algae is influenced by factors such as ice thickness and nutrient availability. Ice algae play a crucial role in the Arctic ecosystem by supporting various organisms. Musk oxen have adapted to survive in the harsh Arctic environment. Their diet consists of the limited vegetation available in Arctic regions. Thick fur provides insulation against extreme cold. Musk oxen form defensive circles to protect themselves from predators. Arctic foxes employ specialized hunting techniques to survive in harsh Arctic environments. Their thick fur provides insulation against extreme cold, minimizing heat loss. Arctic foxes adapt their diet based on seasonal availability of prey. These foxes exhibit remarkable resilience in the face of challenging Arctic conditions. The snowy owl is a top predator in the Arctic ecosystem. As a predator, the snowy owl plays a crucial role in maintaining ecological balance. Snowy owls have exceptional vision and hearing, enabling them to locate prey under the snow. Their thick plumage provides insulation against the extreme cold of the Arctic. Snowy owls are opportunistic hunters, preying on a variety of small mammals and birds. The snowy owl's presence indicates a healthy and functioning Arctic ecosystem. Arctic poppies demonstrate the ability of life to thrive in extremely cold environments. The poppy's structure allows it to absorb maximum sunlight, aiding survival in regions with limited solar exposure. Specialized adaptations enable the Arctic poppy to withstand freezing temperatures and short growing seasons. The Arctic poppy's resilience exemplifies the adaptability of organisms in extreme conditions. Lichens demonstrate the ability to colonize barren rock surfaces. Lichens are symbiotic organisms, a partnership between fungi and algae or cyanobacteria. The fungal component provides structure and protection, while the algae or cyanobacteria provide food through photosynthesis. Lichens secrete acids that break down rock, contributing to soil formation. Lichens play a crucial role in primary succession, preparing environments for other plant life. Lichens are sensitive to air pollution, making them valuable bioindicators of environmental quality. A glacial lake forms through the accumulation of meltwater at the base of a glacier. Glacial meltwater contributes significantly to the volume and size of the resulting lake. The location of a glacial lake is typically at the terminus, or end, of a glacier. Glacial lakes are dynamic environments, constantly changing in size and shape due to variations in meltwater input. The formation of glacial lakes is a direct consequence of glacial melting. The ice sheet's elevation profile visually represents its substantial thickness. Elevation profiles provide a clear understanding of ice sheet volume and distribution. Ice sheet thickness is a critical factor in understanding glacial dynamics and sea level rise. Accurate elevation data is essential for modeling ice sheet behavior and predicting future changes. Glaciers exhibit varying flow speeds across their surfaces and depths. Ice flow speed is influenced by factors such as ice thickness and surface slope. Areas with steeper slopes and greater ice thickness tend to exhibit faster flow rates. Visualization of ice flow speed helps scientists understand glacier dynamics and predict future changes. Subglacial lakes are bodies of water located beneath ice sheets. These lakes remain liquid due to geothermal heat and the insulating effect of the overlying ice. Subglacial lakes can influence ice sheet dynamics by lubricating the base and affecting ice flow. Ice sheet mass balance is the difference between ice accumulation and ablation. Accumulation refers to the addition of ice mass through snowfall and other forms of precipitation. Ablation is the loss of ice mass due to melting, sublimation, and calving. Mass balance is a critical indicator of climate change impacts on ice sheets. Sea ice forms from freezing seawater in cold environments. The process begins with the formation of small ice crystals on the water's surface. These ice crystals then coalesce to form larger ice floes. As the temperature drops, the ice floes continue to thicken and expand. The continuous freezing process eventually leads to the formation of extensive sea ice cover. Sea ice formation is a critical component of the Earth's climate system. Brine channels are pathways within sea ice that facilitate the movement of salt and nutrients. These channels form due to the exclusion of salt during the freezing of seawater. The brine channels support microbial life and serve as a habitat within the sea ice. Nutrients are transported through the brine channels, influencing the sea ice ecosystem. Brine channels play a critical role in the exchange of gases between the ocean and atmosphere. Wind also plays a significant role in the movement of sea ice. Sea ice drift can lead to the formation of leads and polynyas. Sea ice drift affects navigation routes and accessibility in polar regions. The albedo effect describes the degree to which a surface reflects solar radiation. Ice has a high albedo, reflecting a large percentage of incoming sunlight back into space. Melting ice reduces Earth's albedo, leading to increased absorption of solar energy and further warming. Permafrost is ground that remains completely frozen for at least 2 consecutive years. Permafrost is found in regions with very cold climates. The permanently frozen ground contains ice, organic matter, and trapped gases. Thawing permafrost releases greenhouse gases, such as carbon dioxide and methane, into the atmosphere. Changes in permafrost can affect infrastructure, ecosystems, and global climate patterns. Thawing permafrost releases significant amounts of methane, a potent greenhouse gas. Methane released from permafrost contributes to accelerated climate change. The process of permafrost thaw is exacerbated by rising global temperatures. Coastal erosion involves the wearing away and removal of land and sediments along the shoreline. The process of erosion is accelerated by the thawing of permafrost in coastal regions. Erosion leads to habitat loss and displacement of coastal communities. Effective coastal management strategies are essential to mitigate the impacts of erosion. Glacier retreat is the shrinking of glaciers due to melting at a faster rate than ice accumulation. Glacier retreat contributes to rising sea levels and alters regional water availability. Time-lapse imagery vividly demonstrates the dramatic scale of glacier retreat over decades. Changes in albedo, caused by reduced ice cover, further accelerate warming. Glacier monitoring provides crucial data for understanding climate change impacts and predicting future trends. Ocean acidification is primarily caused by the absorption of increased atmospheric carbon dioxide, CO2. Ocean acidification poses a significant threat to marine biodiversity and the sustainability of fisheries. Changes in temperature and ice cover are primary drivers of altered species abundance in the Arctic. These shifts in species distribution and abundance can have cascading effects on the entire Arctic food web. Traditional hunting and fishing practices are challenged by changing ice conditions. Adaptations include new infrastructure and economic activities. Communities face challenges related to cultural preservation and identity. Wind and hydropower are renewable energy sources with the potential for sustainable development. Wind energy harnesses the kinetic energy of wind through turbines to generate electricity. Hydropower utilizes the potential energy of water stored at height to drive turbines and produce electricity. Renewable energy sources offer a sustainable alternative to fossil fuels, reducing carbon emissions. Sustainable development integrates renewable energy to meet current needs without compromising future generations. Sustainable tourism minimizes negative impacts on the environment. Eco-friendly accommodations reduce energy consumption and waste production. Research stations in Greenland facilitate the scientific study of the Arctic environment. Arctic research provides critical data on climate change impacts and environmental shifts. Protecting Greenland and the Arctic is crucial for the well-being of future generations. The Arctic's preservation directly impacts global climate stability and biodiversity. Sustainable practices and responsible stewardship are essential to safeguard the Arctic's natural resources. Collective action is needed to address the challenges facing Greenland and the Arctic.